Okay, so hi again. My name is Gabor Sabo. This is the programming bootcamp, and Nora. Hi.
Hi there.
How was the how were the exercises?
They were fine, I think. I didn't have any issues with these two now. I really like the second one, being a bit more complex with the options.
Right. Yeah. No, that's the idea of getting more complex. Okay. So let's go over the solutions now. I'll share the screen, so you don't have to tell me that to share the screen. So this is the main slide, and then I get directly into where we left in the previous video. So this was the second exercise, comparing the strings, and these are the solutions. So the first one was asking the user for two numbers, and then checking if they are comparing to each other. And I'm not even sure that what we see here is a really good solution now that I'm looking at it. But any case, so I asked the user for two numbers input with input, and I put them in variables called a in and b in, and then I check if they are decimal numbers. So that's the function that we looked at that actually checks if they are integer. So it doesn't check if they can be float. And then that's where I say that, okay, so these are the two checks, and then if any of them is decimal, then I exit the program with the appropriate error message. And then I convert them. Now here is the issue that probably that's not really the nice correct thing, that I use them as float, even though this number is decimal, as we saw. Can only recognize integers. So I guess I should fix this in the slide in the next version. Anyway, I convert them, and so this is an interesting thing. I do that the conversion. I put them in a different variable. So A number, B number. Now, usually you wouldn't put the type of the variable in the name, as I put sort of it, a num and b num, but it's actually a good idea to take the value and put it in a different variable. So I used to write that getting a with the input and then saying a equals to int a or float a, and that works. Python doesn't care. But there are external tools that will complain about it, and rightfully sort of, because if at the beginning a was a string and then a became a integer or floating point number, and it's a sort of it bothers the strictness of some external tools, which in the end it's up to the programmer or the team to decide how strict they would like to go. But in this case, I said, okay, I'll use different variable names just to show that I can put them in different place. And then I use these variables, the converted one already, and compare the values, which one is bigger, and then report that. So that's just an if statement and elif and else if and else. Okay, so I don't think that there was too complex, but still I made an error, so, or not the best choice, more maybe. The other one was the comparing of strings, and here we get the input, again a in and b in, I call them, even though here I'm not going to do conversions. So I get the two strings, and then I said that, okay, let's basically show a menu to the user. So it will print out these text. So let's run this example Boolean compare strings. So where is my leftovers from the previous one? And this whole thing is in the Boolean directory. So Boolean, and then I run it's compare strings. Compare strings. So I run this, I type in 1, and then I type in 2. That's a response, and then I get this menu. and I am supposed to pick 1 or 2, and so I say 2, let's say, and then it says that they are equal, okay, because they have the equal number of characters. So here is that the menu is basically just printing out stuff, nothing special in this case, and then I get the input, how, and I don't even convert them to numbers. I check if how is equals to the string 1, then I okay, so then what I do is I make the conversion and then get two responses. So whether it's smaller and whether it's bigger, whether A is bigger or whether A is smaller, and I put them into two variables. So first and second is going to be true or false, Boolean values. And otherwise, if also elif how equals to 2, then I do the same thing, but the conversion is now on the length of each one. And then I have this whole part where I say if the first one was bigger, so basically the first means that first is bigger. So maybe, so the thing when now I was trying to explain, I actually didn't know why did I call it first and second. So, and only now that I arrived here, I actually recognize that the first means that first is bigger. So maybe it would be much better to call this variable first is bigger, because then I wouldn't have to wonder why I called it first. Okay, so first, this means first is bigger and second is bigger. And so when first is bigger, then I say that's what I say, and else if second is bigger, then I say the other one, and else apparently they are equal, right? So one thing here that I thought about, why do I have these variables and not just make the condition and print out things? And I think the reason I wrote it this way and not just saying, so if how equal to 1 and then do the conversion and print the result, the answers, because in that case, I would have to duplicate the response text, both for this part and for this part. And I wanted to avoid that. So, right, I'm not sure if it's a really good solution in the end, but a working solution. Your solution, how was your solution? Did you?
Well, I did it a bit differently. So I created two new functions. One of them is the comparing based on the ASCII table, and then the other one was comparing based on the length, and had 3 conditions each.
Okay, can you show them, or it's not on your computer that you can't do that?
I think I can show it. Wait a second. I don't know how to. Can I share my screen if your screen is sharing?
No, I'll stop sharing and then you can share yours.
Right.
Just make sure you share the right thing and not something else maybe on your screen.
Yeah. No, it's, yeah, I think this is the one. Can you see it now?
Right, yeah, thank you.
So what I did was first I created.
Wait a second, sorry. I'm not sure. Okay, so I think it's in, okay, for me it opened in my other screen, but I think it's being recorded anyway, so.
Okay.
Sorry.
So yeah, this is what I did here. So I defined one of the functions, and then later on with the if statement with the menu, I only said, okay, if number is 1, then run this function, and if number is 2, then run the other function.
Okay, and where are the print statements?
So in each function, I had to duplicate them.
Yeah.
But
Okay, so first of all, it's nice that you're using functions. We haven't learned them yet officially, or we saw them a little bit, but we haven't didn't go over. So it's really nice. And yes, so this is the sort of issue that now you have to duplicate the output, and sort of this is the trade-off.
Yeah.
Okay, and programmers in general, I see that you actually have you solved something here that I didn't, right? That you have that else part here.
Yeah.
My solution I didn't have.
Yeah, but I didn't put in the check if they actually wrote a string. Like in the previous one, the compare number one, I didn't write in the check whether it's decimal or not part.
Okay, right.
But yeah, here that's not an issue. Right?
No, but wait a second. So here you have this else statement in which we say please enter the number of your choice only. Ah, okay. So you're telling that okay you didn't enter. Okay, good.
Yeah, the print statement, the sentence itself might not be the best, but
right. Yeah. Okay. Well, so that's another thing. Okay, whatever programming, you do your best when you write your program, and hopefully in a month from now you'll know better programming, not just like the English sentence is good or not. That's also an issue, but in general how you wrote your program, and then you can improve your programs. So maybe that's interesting with these little exercises. But when you write an application for yourself, it's a really good idea to revisit your program a few days, weeks, months after you finished, and see how could you, if you still understand what you did. And if not, then that's better to take the time and understand it and make the improvements.
Right.
Make these relatively small changes, for example, of renaming a variable to something more meaningful, like what I suggested in my case.
Mm-hmm.
Okay?
Yeah.
Good.
All right. Stop the screen share now.
Yeah. Okay, so I'm going to wait a second. Sorry, this thing now. Right, okay. Zoom was playing a little bit of tricks on me, and I have no idea what's going on because, but okay. Maybe I'll just change something. Earlier I saw both of us in the little view. Now I can only see you, but I mean, that's okay.
I can see you. That's the important bit now.
Okay. Well, I have no idea how the recording is going to happen.
All right, we'll see, I suppose.
Yeah. Okay, so that's it. But let me return to that point that I just made of improving your code. So in general, there is a word in programming which we call refactoring, which I have no idea if it's how is it used in English in any other place. You probably know the word from other contexts. I don't know in other contexts how it's used. I only know this word in the programming context. And the idea of refactoring is to basically to change your program in a way, improve the readability and maintainability of your program in a way that doesn't change the actually what the program does. Okay, so probably the simplest thing is that you have this code that I'm sharing now, right? Yeah, and I just realized that this first should be first is bigger. So I rename it to be first is bigger in the whole program. And this doesn't change the behavior of the program. So from the outside, from the external viewer, it doesn't matter. And that therefore, it's actually really difficult for businesses to justify the investment in this because, well, the program didn't improve. You don't do it faster. You don't do it better, anything. But the internal maintainability of the program improved, which means that next time when you have to change the code, it's going to be easier for you. So it's an investment in your future. And that's really difficult in many companies and many organizations to I don't know, understand or to go with it. But researchers show that in reality, only about 10%, so the total time investment in a program is about 10% the first time when you write it, and then 90% the time when you maintain it and make changes and read it and so on. And not so much for these exercises, obviously, but most of any programs you write. Even more so for programs that you say, oh, it's a throwaway program, I just throw it now and I won't need it anymore. And then 10 years later, you're still maintaining it. So it's a known issue. Okay, any questions here? Any issues?
No, I was just wondering that, do usually text editors have a function where you can, you know, search for one variable, for instance, and then change it? Like in Word, there is this search and replace function.
Yeah.
Do the other text editors have this as well?
So, sorry, which editor you said that there is? It's Word. Word.
Yeah.
Okay, so yeah, all the, I mean, Notepad++, every editor has the search and replace function. What is missing from most editors is a context sensitive search and replace. And actually, that's one of the things that PyCharm does really nicely. If I'm already marketing it, or rather, I don't know, I have no idea, maybe Atom has similar feature, or other editors have similar feature. But PyCharm, because it's so much focused on Python, it's much, in a way, it can be do much better. So think about it that if you look at your code now, your solution, you use the same variable name in both functions, right? The internal, I think you had some internal variable, and you used it in both functions. So if you do a search and replace, either you do it one by one, or it will replace in the whole file. So even though those two variables have nothing to do with each other, one of them is part of function 1 and the other one is part of function 2. They have nothing to do with each other, but they are the same word. So in a search and replace, they would be code. PyCharm has this capability of it, and it's called refactoring. And I'm going to show it later on when we talk about PyCharm, that you select a variable and it will understand which are the other appearances of that same variable. And if the same word appears in a different function, PyCharm understands that that's a different variable. So it can rename just that variable, which is way more powerful than just a general search and replace.
Right.
Okay, and I'm not familiar that much with other editors. Maybe other editors offer similar capabilities. That's very powerful. And just one more thing about refactoring. So I gave you this example of renaming a variable, renaming a function, all kind of other things, obviously the same, but they can also be like, so when we get to the functions, I will talk about it more, that a recommendation is that you write short functions, that each function does one thing, and it's gonna be like 5 lines, 10 lines, depending of the school of thought. Some people say maximum how many lines, whatever. The point is that they should be relatively short. But the reality is that most programmers, especially beginners, but I mean, I also do it all the time. I notice it, that I write functions and then just think about stuff and write, and then end up with a function which is 100 lines long, which is not very maintainable. And then comes the refactoring part, that you take out one piece from this function and move it to another function. And this is also a refactoring exercise or step. And PyCharm can support this as well. And there are all kinds of these things that can improve the maintainability and readability of your code, which is a value that not all of us manage to value, whatever. Okay. So next chapter is strings. We're going to talk about strings. I see it's a long chapter, and okay, whatever. We'll stop if it's getting too long. Okay, so the string. So we already see that you can put anything between 2 double quotes or between 2 single quotes, and these are strings. So it doesn't matter what you put inside. letters, spaces, ampersand, that just goes everything. And Python doesn't care if it's double quotes or single quotes, as long as they are the same on both sides. And I mentioned, I think that I mix them up because I keep forgetting it. Some people care about it, that you only have one type of quote in the whole program. I guess it's nicer if you have only one type of quote, but that's not that critical. Anyway, we have these two variables now. I can print them out, and their content is the string. So what can you do with a string? Oh, this is a horrible slide. I think I should jump over it. Just one point one thing I wanted to show here, that if you put two strings one after the other without anything between them, then they become sort of the same string. So this text is actually A, B, C, D, E, F. And then you can make all kind of, so this is the same as this. And I really don't like it. I'm not even sure why Python has this thing that, whatever. A couple of other examples that we shouldn't go in because it's just too much details in an area that we don't really use on a day-to-day basis or even on a year-to-year basis. So, okay. But if you would like to create a string that has multiple lines in it, in the string, then one of the best ways to do that is to use this triple quote of Python. So basically this 3 times double quote at the beginning, and then you write text, and then somewhere later, a couple of lines later, you put again 3 double quotes. You could also use, by the way, 3 single quotes here. So just you need to have 3 times the same quote, one after the other. That means this is like a multiline string. And the question might rise, why not do two quotes? Because why jump from one quote to 3? And I thought a little bit about it, and I guess because if you have 2 double quotes, then Python might think, oh, this is an empty string, and then don't know what's after it. So I think that's the reason they had to go with 3 quotes, to make it clear that it's 3 quotes after one after the other wasn't anything that that was legal in Python. So now it is, and this is what you can do. So when you print it out, you will have these lines.
Actually, what would you do if you wanted Python to print out a quote? So if you wanted it to actually print out the quote itself,
right? So
would you use 2 different, like, single quotes and then the double quote, or?
Right, that would be one choice. So you say how do you write it?
What do you want to write?
Whatever, I don't know. Something just in English, doesn't matter. Okay, so the single quote, wait a second. Print, let's do this way. Okay, so now it says the single quote, okay? So I put between the double quotes, the single quote. And if I want to print out the double quote, then I could put here the single quote, here the double quote, right? That's what I want to print. And then you have the double quote.
Right,
that's
okay.
one way. The other way would be, if you want the double quote, is to escape it. Okay?
Oh.
So if you put a backslash in front of a special character, it's a general thing, it's called escaping, then, right, that's actually a good point now to talk about. So you can escape a character, the quote character, by putting a backslash in front of it. Okay, so how would you print out a backslash now?
2 backslashes?
Exactly, because if you put in 1 backslash, then, well, it worked in this case, but let's say if I put it this way, then this does something else. Okay, let's show this one.
Right.
Okay, so what is this now? So now I'm printing out HE \tll, which is probably what I meant there. So if you have a special character like the quote or the backslash itself, then it's better to put a backslash in front of it to escape it. But there are also characters that if you put them if you put a backslash in front of them, then they will have a special meaning now. So
like the new line.
Exactly. So the n, if I put a \n and I print it out, then it actually printed a new line. So that's the reason it broke into. Well, let's remove the initial spaces here, so you won't have. So you see, so the \n actually told Python to print the next parts on the following line. So it's a new line. It's the representation of a new line in Python. Okay, in actually most every language. I can put another one here, and then now we have an actually empty row there because now we had two new lines. The other one that I showed here is the T, which is a tab character.
Right.
So a tab character means to jump a little ahead in the text, in the line. And how wide is the tab is a whole separate story. We don't get into that now. But in case you would like to represent something is tabulated output, then that's how you can put it in your Python code. Because if you would put an actual tab in your code, then you wouldn't be able to actually see it because it's just a space. It just spaces. You don't really see that there is something. So it's better to explicitly say that's a \t. Okay.
Is it an okay thing to use a tab instead of like spaces when you indent in your own code?
So technically it's okay, but I think the recommendation is just the 4 spaces.
Right.
But if we are already asking, let me try to show this thing that I wanted to show earlier. Okay, do you want to reload it? Yes, something, I changed a file there. So let's, I'm getting in this editor, and this, I don't know if you're still using Atom or you started to play with Notepad++. In Notepad++, at least, you encounter this issue. In other editors, maybe not. So I created a new file here, okay, by pressing, okay, so let me create it in a different way so we can see it here. I created a new window. It's not a file yet because I haven't saved it, but it's a new window. So I can start typing in. I say if, if 2 is less than 3, and then I pressed actually the tab, okay? And I say here, print whatever, I don't know, hi, just some code. And then I come here, and here, for some reason, I decided to press the 4 spaces, okay? And then I say print hello, okay? Now visually, we can't make can't notice the difference. So now I'm going to save this, and I save it where basic examples, basic hello. Now I wonder where did I save this because I wasn't sure where was this. So exit. So examples, basic. I think this was, so one thing that I show, another thing in the same time, type, that's a Windows command that shows the content of a file. Okay, nothing to do with Python, just to remember, because I wanted to check that this is indeed the file that I was editing. Okay, so this, no, this is not, right? So it's, oh, it's hello txt. Hello txt, do I have it here? Yes. Type, okay. So now here I actually can see the difference, but in the editor I couldn't. Okay, so if I run this, hello. So 2 things here again. Okay, I'm showing a little bit too many things at once, but I can run this even though it's called txt. Python doesn't care the extension. It just got the file and then can run it. Now, when I run this, it will give me a syntax error. And what is the syntax error? It says indentation error, because the indentation wasn't correct. Okay, and when I ran it with type, when I showed it the content of the file with type, then we could see it, because this represented the tab with with 8 spaces, and here I have the 4 spaces, the actual 4 express spaces. But this editor represents a tab character with the same width as 4 spaces. So again, sorry?
If you're being consistent with it, then it's not going to be a problem, right?
Right. Yeah. If I'm consistent, so if I have here also this way, I think automatically it would put me in the tab. So if I save this now, and if I manage to get back to that window and I type, then now you can see that type also sees them on the same level. If I run it, then it runs now. So that's not a problem. But this thing happened to many of my programmers, many of my students. And partially because sometimes they typed in spaces, sometimes they just hit enter and they got the tab. And so, but how can you see this here in this editor? And that's something especially to Notepad++, but probably something like this exists in every editor. So here I can go to the view menu item and say show symbols, show white spaces and tabs. I click on this one, and now I don't know how much can you see it because of the screen, but the first one has an arrow and the second one has 4 dots. Because now you can actually, it visualizes the tab and the spaces. Okay, and so so that's it. The thing is that we also didn't understand for a long time how does this actually happen, because if you write your Python program here and if I press enter, I get the 4 spaces, and even if I type press the tab character, I get 4 spaces. So I didn't understand what happens here in this file, that when I type in tab, I get an actual tab. And then someone found out that because it's a text file. And when you start writing a new file like this, then the editor still thinks it's a text file. And so inserts tabs. So was the confusion. So if anyone got up till here and was really, really frustrated with using Notepad++ because of this, that's sort of the explanation. It's better to start off by using .py, because then the default is 4 spaces, and that's sort of the recommendation. So there is something called the Zen of Python, and one of the recommendations I think in the Zen is to use 4 spaces for indentation, whatever. But let me just show you another thing here, if we already was there. So here now I have, one of them is 3 spaces, the other one is 4. And if I run this now, still indentation, okay, unexpected indent. So if it's too much or too little, so what happens here? Do I get different message? Yeah, so it's the first one said indentation here. Where is this? Indentation error, unexpected indent, and the second was unindent. So because it was shorter, the second one was shorter. But the point in both cases is that the depth of the indentation was incorrect. Right. So anyway. Of course, it's better to use .py extension, because then, I mean, you also saw it, I didn't have syntax highlighting there. I didn't have the syntax coloring. So it's better to use the .py extension. Any more questions here?
No, I think it's all good.
Okay. So we were talking about the triple quotes here. So you can put a string in triple quotes, and then you can have it in multiple lines. And it's useful many times when you write documentation, or when you write a long report and you have long text that you need to have it in the program as well. So that's what you can do. The lengths that we already used actually in the exercise earlier, but so apparently I'm introducing it here only. So len of a string gives me the number of characters in it. Okay, and here it says hello, it's 12 because the new line also counts as one character. Okay. You remember that we use the plus operator on the strings, right? So you can concatenate them. So here I have a string plus another string that concatenates the two strings, but we can also have repetition of strings. So we can't multiply a string with a string, but we can multiply a string with a number. And then it will just repeat the same string. So here I have jar with a space, and then twice, which becomes jar space, and then I add Binks, and then I get jar jar Binks. Okay, so very useful way of expressing our thoughts. I think the most use of this multiplication is if you need to write a textual report and you have some title and you don't know how long the title is going to be, but you want to put an underline and you put a line below it. Okay, and then so you have some title which you got in from a variable, and then you put these dashes, as many dashes as the length of the title. Okay, I know, it's a brilliant way of programming, but I mean, these days, most of the reports are going to be in a PDF file where this doesn't count, or an HTML file where this actually doesn't matter. So it's not that important, but if you send it as a text report, then it can be useful because it's whatever. Okay, so now we have a string here called text. That's the name of the variable. I can access the specific characters in the string by using the index. So text in zero space is the capital H, and text, I don't know, maybe if it's larger, it would be better, the fonts here. Okay, text in the sixth place is the capital W. So it starts with 0 and then 1, 2, 3, so on. So you just can get to a, if you know the location, you can get what character is there. Okay. You can also, yeah.
Does this whole so when you write text with the squared brackets, does that mean it kind of handles it as a list?
No. It's a sequence object. So there is the types have a hierarchy, and if I recall correctly, there is the name of the top name is called sequence. So that's the it's sort of the hierarchy sort of features. So because both a list and a string is a sequence type thing, in both of them you can use these indexes. Okay.
Right. Yeah.
So it's just you can't. So there are all kind of other things that you can use index, but not with everything. But they have no necessarily. So this is the connection between them. They behave this.
Right.
Okay.
Okay.
But it all boils down to the point that in Python, one of the design goals was to make things look similar. So you don't need to use different constructs to get an element. So basically now we get an element of a string, which is a character. And if it's a list, then it's an element of a list. So, and it will be the same construct. So there is also something we call a slice. Okay. In other languages, it's usually used a substring or something like this, a function. In Python, we can use slices, which look like this. So I say again a string variable name, the name of the variable, and in the square brackets, I put in 2 numbers with a colon between them. And this is a range of the characters. So it means start from character 1. It's actually the second character, right? Because character 0 is the first one. And go up till character 4. But again, here, the upper limit is not included. So it's character 1, 2, and 3 in this case, which in our case is ELL, right? And that's what we get here. So this takes in the slice of the string. And you don't actually have to specify both ends, both numbers. If you specify only the lower number, like in this example, then you will have 2 till the end. So the second character till the end. So now it's the H and E is the 0 and 1. So the number 2 is the first L, and then till the end. And on the other hand, I could say colon 2, and it would mean the same as 0 colon 2. So starting from the beginning up till 2, but of course the character number 2 is not included, so it's the character 0 and character 1, which is HE in this case. Okay, and we don't even need to hard code the numbers here in the expression. We can use variable names, and the fact that I used it start and end is just to make it clear to myself that this is the start. You can use any variable name there. Okay, and again, the text is also just a variable name, and then I can put in start and end here in on the 2 sides of the column. So it can be a dynamic thing. On one hand, the text gets in there somehow in a dynamic. Maybe you're reading it from a file, and then that's the text. And then the user types in the start and the end number, for example, or you get it from some other place, and then that's how you extract some data. Okay. So how can we change the string now? Okay, we know how to get one character or a slice. How can we change it? And this is basically what we would like to do. We have a string, and the number is the second place, so third character, replaced with a capital Y, and then print it out. But if you run this, we get an exception. Okay, you can't do this. You can't change the internal part of a string, the content of the character in a string. Okay. And you can't do this because in Python, strings are immutable. Okay, so there are objects, or there are variable types that are mutable, so you can change the internal parts of them. We'll see them, for example, list. With a string, you can't do that. So how can you, okay, so how can you actually get to the point where you wanted to get, to have A, B, capital Y, D? Because that's what we wanted to have in this case. You can do that, but the only way to do it is replace the content of text with the new string. So that's what we see in the next slide, that we have the text, and then we build a new string from the beginning of the original string, the letter Y, capital Y, and then the end of the string. And now I concatenated it, I build up a new string, and I can assign this back to the variable called text. So now text will contain, or will point to this new version, which is AB capital YD. Okay, this is the only way. And of course you can ask, why is that? And the general consensus these days among programmers that it would be much better if everything was immutable, then we would have less bugs. So in Python, some things are immutable. It's partially, so partially I think it's a detail of the implementation, how things are implemented behind the scene. Partially it can be thought as a good thing. Makes life a little bit harder at first maybe, but people say that it's on the long run, I mean, when you start fixing your bugs, then you will have less. Okay, so what happens if I assign something to another string? So here I have to another variable. So here I have a string. If I say text plus EF and I assign it back to text, then the text is gonna contain the new string. So whatever we created. That's basically what we did the previous slide as well, with a different, slightly different thing. So what happens now if I take this text and assign to some other variable name called other? Okay, and then I do, and then I replace the content of text. Okay, so text is going to be the new value, and other will point to the old value, because this thing is a copy operation. And I don't know if you expected this to be a copy operation or not. Did you think that it's an alias to it? So it's just a different name for it?
Yeah, that would have been logical to me.
Okay, so because the strings are immutable, well, okay. So actually, right. So actually, this wasn't a this was okay. So actually, you were right. This wasn't a copy. But when we assigned a new value, then it started to point to a different place. So behind the scene, actually, you have these strings floating in the world, the string A, B, C, D, E, F, and the string X, Y, Z. And here text points to the A, B, C, D, F, and now other also points to the same place. So it's not really, at this point, the copy doesn't really happen. But when you assign X, Y, Z to text, then text suddenly starts to refer to some other place in the memory. And then they get separated. Okay? So that's what actually happens behind the scene. But for our purposes, it looks like it's a copy. Because the strings are immutable, because we can't change them, only replace them. Okay. So functions on string, I actually don't know if there are any other functions on strings besides the len function. But there are many methods. And now the slight difference between these two words. You see, here I have a.upper. And this is a method. So in the end, they're both functions and methods are almost the same. The difference is that a function gets a parameter and works on that parameter, while when you have a method, then you have the thingy object, and then you have dot and the name of the method. And it can get all kind of additional parameters, but the main thing that it's working on is at the beginning. Okay, so here len is sort of an external view on the string, and method is more like an internal capability of the string. And I'm not sure why len is a function actually in Python, but that's a separate story. Okay, so why was it implemented as a function and not as just another method? Anyway, so here we have the len that gives the length of the string, and here are the methods. So there are some relatively simple methods, for example, upper, that converts the string to uppercase. But remember, strings are immutable. So even though this converted the string to uppercase, it didn't change A because it's immutable. What it did, it returned us the uppercase version that we assigned to B. So B is the uppercase version, and A remained the same exactly as we had earlier. This is how it works for strings and other immutable types. If you look at, later on, we'll look at mutable types, and there it actually changes the internal part. And similarly to upper, there's also lower, and there are all kind of other functions. So methods, sorry. Lower does the same, well, it returns the lowercase version of the string. Okay, and here I have a link to the list of all the built-in functions, so like len. And these are all the built-in functions of Python. Ups, absolute numbers, and yeah, next time we have the video, you'll have to remember all of them by heart, okay? Yeah, so that's the bad joke I try to make. Anyway, so there are a number of these built-in functions, and then you look them up when you need them. Okay. Actually, I'm interested now. We're covering probably, I don't know. I actually don't know how many of them we cover during the course. The other link here is the string method. It brings us to the documentation of the string object of string type, and you can see all the methods that you can use on strings. Okay, so that's it. Another method. So we're going to go cover. Yeah, you wanted to ask something?
Yeah, just quick. I don't know if it's possible or not, but as we were talking about, searching and replacing in text editors, could you write a program that does that to an input?
Right. So yeah, that's usually you would do with a regular expression.
Right. Okay. So we'll get to that later.
When we get there, yeah, yes.
Okay.
There is, yeah, usually you do this with regular expressions because you want it to make, actually, even if you open, so if I open now here, the text editor, and I run search, so I have the search, right? It has, I can search for something, okay? And also it has the replace window, right? And actually, even in the search one, I could say search mode normal or search mode regular expression. So you can, even in the text editors, most of the, at least the programmer editors and IDEs, you can actually use these regular expressions already to make a much more flexible search and replace. So I'm just to give an example, you're looking for all the words that, all the words Python, but you don't care if it's capital P or lowercase p. But on the other hand, I don't know whatever, so it's not case insensitive totally, but you don't care there, for example, or yeah, that's the standard example, and for you it's even better because you're in England. You look for the word color, and you want to make sure that you catch both the American spelling and the English spelling. So there, a regular search gonna be difficult. Search with a regular expression is just too easy. Okay, so we'll see that thing. Yeah, so a couple of more of these methods that we have on strings. One of them is called index. Index will return the location of a string inside another string. So I have here the text, and then I call text.index, and I give it a shorter, I mean, normally shorter string, because a longer obviously wouldn't be found in there. And so it can be anything, okay? That's not words, nothing. And in this case, I used words here because it seems nicer, sort of, but it can be a DNA or anything, okay? So it can be any text or any series of characters, okay? So I'm looking for BL, and it will return 4 because it's 0, 1, 2, 3, 4. That's where BL starts. And if I search for the with a capital T, then it will find this the. Actually, I should add to this example. It's example strings index. That's nice. Now I just noticed it. Examples strings index. Let's try to this one. So what happens if I look for the word the with lowercase t? Okay, and now let's run this. I keep forgetting where I am. It was strings index. Strings, and now I run Python index. So it gave me 22. Okay, so I'm editing here, adding it so you can see it when the slide is generated. But why is it 22? Because it finds this the. Okay, so this is case sensitive.
What happens if there is multiple ones of the same word in there?
Right, you will see it in a second.
Right.
Okay, but the last thing here was that the dog, so I was looking for a dog, there is only a cat here, no dog, so you get an exception here. It says substring not found. Okay, so we'll want the first, so we'll also want to get rid of this thing, but first let's answer your question. So what happens if I look for something that has multiple appearances? So text index C, I'm just looking for the string, which is the letter C, because that's what I had here repeated. Maybe there is something else repeated here, but I don't know what. So, so C, it finds the first one from the left side. Okay, but if I want to find another one, I could actually run index again, saying look for the C, but starts from character 8. So this is it's 7 because it's 0, 1, 2, 3, 4, 5, 6, 7. And then the next one starts from the letter K, that's the location 8, and then 9, 10. So it won't say 3, that the third from here, it will say 10 from the beginning of the string. But it will start the search from their 8th character. And I can also tell it to look for 8 till 16. So in between a range. So start from location 8 and up till location 16, look for this thing. So maybe basically it takes a substring, a piece of the part of the string, and in that looks for it. But the end result, the number that I get here, is based on the original length of the string, the original beginning of the string. So here too, actually, I got an exception because the GR wasn't found in this range. There is another function called rindex that does exactly the same, but searches from the right to left.
Right.
So if you have...
Sorry, just a quick question. So yeah. Could you make the script print out all of the ones that it found?
I could, but that's an exercise for you, actually.
Ah, okay. Okay.
So we'll have it as one of the exercises. So rindex does the same, just looks from the right-hand side. It still gives the number from the beginning of the string, from the left-hand side of the string. And it's funny to say now left-hand side because in many beginning, or because of course those people who write from right to left, for them the right side is the beginning. But so that's why it's much better to say left-hand side and right-hand side of the string. So when the rindex starts from the right-hand side, but the counting, so the number is still from the left-hand side. So in this case, I've looked for the C and it found, I don't know where, this C, I think, which is 14 from the left. And the same with range, and everything else is the same. Okay, so the question, so one of the questions here that you asked, how to find the other ones, we'll get to that. But there's another issue here that I'm looking for something, especially the first example when I was looking for a cat. No, I was looking for a dog. And not just, it didn't tell me, no, I can't find it. It throws an exception? It threw an exception, that's even better. So it threw an exception, and now it's in past. So, which is not really what I expected. I mean, I was like innocently asking, is this there? And it said, bang, and everything is gone. And now I have to rub the whole thing into exception handling and whatnot. And well, this is how it behaves. So we'll have to deal with this, or we can prevent it. Or there are a couple of other solutions for just wrapping it into a try except block. One of them is that Python also provides a function called find, a method, sorry, called find for strings. It works almost exactly like index, except that if it can't find the result, it will return -1 instead of raising an exception. Okay, so it's a, let's say, friendlier way of doing this because you don't have to capture the exception and see if things went if you didn't find the thing that you were looking for. Okay, so that's one solution. And then we'll see soon another solution. And there's nothing more to see here. That's the only difference here. Okay, and why -1? It's because 50 years ago, when people developed the language C, they had a function doing this, and it returned -1 as saying that it couldn't find something. And so this is this historical thing. But it's interesting that all these things from decisions made 50 years ago are represented in our programming languages up to today. So yes, this was your question, find all in the string. So once we learn how to use loops, we'll do this as an exercise. Okay, so there's another operator for strings and also for other data types. It's called in, the in operator. And it has two major uses. One of them is what we see here now, is that we can ask if something is in something else. In this case, we ask if the WO substring is in somewhere in this txt. It won't give us where. It will only give us if it's inside, if it's in there or not. So this expression is it returns true or false. Either who is in txt or not. And based on this, it will be printing. And here I can check if the letter X is in the txt, in the text txt, not in the variable name, and then print it accordingly. Okay. So what I could do here is I could use the index. So I could use the in before the index. So I can say, okay, I'm looking for this substring in this text. So now I check if sub is in text, then get the location with index. Now the index is protected because I'm going to call it only if I already know that the string can be found. Unfortunately, this means that Python needs to search the whole text twice, which some people will got really nervous about it and say, oh, that's going to be slow and why do we have to waste the time? But in general, I don't think that's an issue because, I mean, if this gets to be an issue, then probably Python is not the right solution anyway for your problems. If this level of speed change matters. But of course, it can be changed, so it can be done differently. But if I already talk about speed, so when you read something from the disk, compared to when you do some search in the memory, so reading from the disk is about 10 to 100 times slower than doing anything in memory. So if your program needs to read something from the disk and then do something like this in memory, then probably all of this memory handling, all of these searches, they don't matter so much because the reading from the file is the heavy part in those areas. Obviously, if you do this 10 million times, then it might matter. So in the other case, when we are looking for the dog, now I check it, and because it's not in the txt, Python won't even execute this part. So this is another way. So either you use find or you use in before index. Right, and this is the opportunity, or this is the place where I usually talk about the ASCII and the character, the various character, the encodings, various encodings. So a little explanation. So in a computer, basically, so you have these bits, right? 0 or 1. That's what the physical layer of the computer can handle. And these are basically something that has either electricity or not. That's the lowest, the transistor. So there are actually transistors, little ones. They can either have electricity or not, and therefore we either count them as 1 or 0. And that's what the computer knows and nothing more. And then these are what we call bits. And then there are units of 8 bits, which are called bytes. And back in the really old days when computation started, people only cared about the Latin letters and digits and so on. And that's when this ASCII table ASCII was created. And the ASCII table actually used the only 7 bits needed. So that was only, so okay. So with the 8 bits, you can represent numbers from 0 till 255. And with 7 bits, you can represent numbers from 0 till 127. That's half of it. And so we already saw the ASCII table, but that's basically what we have here. These are the numbers in the middle one. These are the decimal numbers. These are hexadecimal representation and octal representation, and binary representation doesn't really matter for us now. And it's until 127, okay? And you can see all the exactly which sign or which character is what. But then came out all these strange people who wanted to, like the Hungarians, who wanted to put all kind of umlauts, and the German also wanted to, and everyone, and the Norwegians had this O and whatever, and but they still had only these 8 bits. But they said, okay, we have this one extra bit that wasn't used. So all the numbers from 128 till 255 that weren't really in use. So they decided that we'll use these numbers to represent OR letters. So they created a mapping saying that whatever the A with an apostrophe in Hungarian, let's say, is 197, whatever, I don't know, I'm just making up some number. And so they created these mappings, which is just a table, but then the programs knew that if the file was in this Hungarian mapping, that they knew what character to show on the screen. Because in the end, at the end, in the files that you save, you don't really have the letters. What you have is only these numbers. The problem is this, that, well, you only had 128 extra places, and it wasn't enough for all the languages, and especially when the Hebrew-speaking people and the Arabic-speaking came on, or those who use Hebrew and Arabic letters, they needed different letters, and the Chinese needed even a lot more, and the Korean and all these people. So that wasn't really working. So that's when basically that's when a consortium started to design the Unicode Unicode characters table here. This is just an article about Unicode, and it mapped all the characters in the world. So it had the design of mapping all the characters in the world to numbers, unique numbers, to allow us to represent something. Where is this? So now you have each one of them here has a number. Obviously, you can't fit into 1 byte now, so they use a lot more bytes, a lot more bits for that. But at least you can have everything. I don't know. There are all kinds of places where you can actually see the various characters and how do they look and whatever. Yeah, I don't have anything to show here. You see, another mapping. So these are the character sets. And these are interesting because well, maybe it's not that interesting for biologists and chemists because they only deal with a really small subset of letters in their day-to-day work. But then when they start writing a text, then they suddenly start writing in all kinds of languages. So that at that point when it's starting to be interesting. Anyway, so this is a little bit background for something that I'm going to show in the next slide, if I don't jump over this. So let's say this one, and it's especially important for Windows users, this part. So you would like to have in your program a name of a file, a path to a file. In Windows, this is how a path to a file looks like, right? C, users, foobar. And by the way, if you don't know what foobar means or foo and bar means, it's just some terms from the American military from the Second World War, I think, or the first, I don't know. And the programmers just keep using these words when they don't have a, when they just want to have some random strings. Okay, so doesn't matter. So anyway, this is the path, right? And I put it in a variable, file a equal to this path. So what happens if I print this out? So let's start with the simple one. I print it out. And well, two things can happen. If it's in Python 2, then I get this output. If it's in Python 3, then it will raise an exception like this. Okay, this output comes because, so what happens here is that you remember the backslashes. So Python 2 understands that there is this backslash u, but it has no meaning to it, so it's just u. And it says backslash f, it has no meaning for it, so it's just f. And it says backslash r, and backslash r actually means a carriage return. So if you have ever seen a typewriter, an old school typewriter, where you would type, and then you pull the thingy and push it to the left. So that's what's on the typewriter is the carriage. And then you pull it, that's the new line, and you push it back, that's the carriage return. And because of that, on Windows computers, when you type a new line, it is actually represented with two separate characters, a new line and the carriage return. And in Python, the backslash r represents this carriage return. So what happened here when I was printing it out, when Python was printing it out, it printed up till this point. Then it encountered the carriage return. So it went back to the beginning of the line. It didn't go to the next line. It went back to the beginning of the line in the screen and started to type idme.txt. So that's why in the output you see idme.txt. It overwrote whatever was there. So the beginning of the path. Okay, not good. Okay, so not what we wanted. In Python 3, on the other hand, Python 3 has a meaning for backslash u. And in backslash u, it's supposed to look like this, backslash u and the number, which is the which is the number of a Unicode character. But we had just some text there, which didn't match to any Unicode thing, because we didn't even intend to have this Unicode. So Python 3 said, okay, I have no clue what to do with here. Because I was looking for some, it says can't decode bytes. So it's, okay, that was supposed to be some Unicode stuff. It's not what I was expecting, so it blows up. All this is probably not that interesting. What's interesting is how do I solve this problem? Okay, so the way to solve this, there is the ugly way, which putting a backslash in front of every backslash. And there is the nice way, which putting an R in front of the whole string, meaning this is a row string. Okay. So if I put an R in front of the double quote or single quote or triple quote, doesn't matter. It means to Python that's a row string. So don't interpret these backslash thingies, because they are just backslashes. Okay, and one of the places to use them is one of the places where you really need them is when you would like to include a path to a file in Windows. The other very useful, very place where you really need them is when you're going to talk about regular expressions. Because in regular expressions, we have many signs like backslash S and backslash D. Not many, but a few, but they have meaning, okay? So we would like them to stay as backslash whatever we wrote, and that's how it should work, okay? So these are the row strings, okay? Ord is a function, and another built-in function in Python that can, you give it a character and it will give you the ASCII code of it, or actually the Unicode character of it. So here you can have an A, a Hungarian O, or whatever, maybe other languages also. And this is a Hebrew Aleph, which is, you see, this is way out of the ASCII table. It's 1488. Okay, and I should probably also include an emoji here and whatnot, because so to see that these other things as well. Okay, this, I have no idea why I have this example here. This I have, right, well, I get a name of a file. So this program, ordpy, expects a file name on the command line, right? Remember, sysargv gets one from the command line. argv0 is the name of the program, and argv1 is the one that I put on after the program. So this is a file name. I expect there a name of a file, and this we haven't learned, so don't worry about this. Okay, let's just skip for now. Basically, I'm opening the file, reading the content, and printing out the ASCII code of each character in the file. But yeah, haven't learned that yet. CHR is the opposite of ORD. You give it a number, and it will return the appropriate character. So here I was again using something that we haven't learned, a loop on a for loop on a range. It's just printing out the numbers and the appropriate characters from the ASCII table. Again, not that interesting for now. Okay, let's hope that in the exercises I don't use all these things that we haven't learned yet. Let's go over the exercises. But do you have any questions here?
No, I think it's all good for now.
Okay, so first, okay, write a program that accepts two strings and checks if one of them is in the other one, or which one is in the other one. Another program that gets a character from the string, from the command line, and prints out the ASCII value. If you can, write a program that gets a string, not only a single character, and prints out each one of them. For this, you might need to use a loop already that we haven't learned, but you can cheat if you want, because there you could already see that. Another exercise, you get a number from the user. Now, how do you get from the user? It's either through the argv, so the command line, or you ask the user and then the user has to type in. That's up to you. So you get a number on the command line and you print out the character. And basically that's it. I didn't have more exercises. We are going to get a lot more and lot more interesting exercises once we know how to loop over things. And once we know how to use lists and dictionaries, there are a lot more things to do. For now, it's relatively simple things that we can do with the tools we already have. So, right, this is a different place, different button. So that's it for now. Do the exercise, and then we get back to in the next video with your questions and with the solutions and the next chapter. So, see you.
Yeah.
Okay.